Good evening, everyone. Welcome to Grow Up Online Choosins and welcome to the class of Ncert line to line explanation of haloalkanes and haloarenes. First of all, my introduction. My name is Apul Naidu. I pursued my MS in Organic Chemistry from Andhra University. I have 4 years of teaching experience in Neet and Iit Jee students. In this series of lectures, we are going to discuss about the each and every lesson from Ncert from intermediate first and second year, the explanation of each and every line from every lesson, okay, which was very important for NEET and IIT JEE exams. We observed that, for example, NEET examination, we observed the most of the questions out of 95, out of 100 percentage, we have the 95% questions are from the NCERT. So we observed that that much of NCERT is important for NEET examination. So everyone read NCERT line to line, but the logic is that no one get the full marks. Why? Because everyone read the NCERT line to line, but they are not understand the every line of NCERT. That's the key point to get the out of out marks in a NEET examination. Everyone read these lines. In case of LKG student also read these lines, but you have to understand each and every line and elaborate in a manner to get the full marks in any examination, like in NEET and IIT JEE also. I am trying to explain each and every line. Just you have to spend some time with me. Okay. Okay. Now let us try to understand today's topic is haloalkanes and haloarenes. This is the whole introduction video of haloalkanes and haloarenes. Now let us try to. I am requesting everyone to keep those who are watching this video keep an NCERT textbook with you. It's a very simple for understanding, for easy understanding purpose. Okay. Now let us try to understand the. Now let us jump into the today's topic, the introduction of haloalkanes and haloarenes. Okay, now let us try to understand this main heading by taking a whiteboard. Okay, here is the main one, that is haloalkanes and haloarenes. Haloalkanes and haloarenes. Now let us break this in two parts. That means halo plus alkanes and halo plus arenes. We know that halo means halogens. Halo means halogens. We simply know that the 17th group elements. I hope this concept is clear to you. Halogens here, the main side heading is breakdown into two parts. That means halo plus alkanes. Here halogens we means halogens which are fluorine, chlorine, bromine, iodine. These are called the halogens. And now let us try to understand the second part, that is alkanes. Alkanes we know that which having the general formula which is learned in NCERT first year. General formula, alkane general formula is CnH2n plus 2. Here we observe that for if in a case for n value is equal to 1, it will become CH4. Okay, now CH4. So this is called the methane. CH4 is also called the Mars gas. CH4 is also called the Mars gas. Okay, I hope haloalkanes is clear to you. Okay, now let us recap this one. Halo means halogens which are having the fluorine, chlorine, bromine, iodine. Alkanes are having the general formula CnH2n plus 2. CnH2n plus 2. For example, if in a case n equal to 1, it will become CH4, that means methane and Mars gas. Okay, now let us try to understand this. I have what does mean by haloarenes. So in the previous one, halo means halogens, which are 17th group elements, fluorine, chlorine, bromine, and iodine. Here the arene the arene which means arene or aryl. Okay, arene or aryl, which means benzene. Simply the arene or aryl, which indicates simply benzene, which indicates simply benzene. So we know the molecular formula of benzene is C6H6. Its structure is Here is the structure of benzene. I hope what does mean by haloalkanes and what does mean by haloarenes is clear to you individually. Now let us try to understand in a combined form haloalkanes and haloarenes and how they formed from hydrocarbons. Okay. Now let us try to understand the next concept. Okay. Now let us take an example here. Haloalkanes. Here, the haloalkanes which are produced by a replacement of one hydrogen from hydrocarbons, replacement of one hydrogen from hydrocarbons, you will get the okay, sorry, replacement of one hydrogen by halogens to get the haloalkanes. Now let us try to understand this concept by taking an example. Here is the example that CH4. Okay, its name is methane. Okay, this is an hydrocarbon. This is an one hydrocarbon. We know that this one is okay. You can write CH4 as in this way, and we observe that here one hydrogen is replaced by chlorine, and this is as H minus. This the here we observe that the chlorine is replacing the hydrogen. In place of a hydrogen, the chlorine is substituted. The chlorine is substituted here, Cl, here bond hydrogen. So this type of compounds, this is simply written as a H3C bond Cl. So this type of compounds are called the haloalkanes. This type of compounds are called the haloalkanes. I hope what does meant by haloalkanes is clear to you. Now let us try to understand. It's simply the replacement of one hydrogen from hydrocarbon by halogens is called the haloalkanes. Now let us try to understand what does mean by haloarenes. So simply we observe that here is the benzene. Here six hydrogens are present. Six hydrogens are present in benzene. Here one hydrogen in benzene is replaced by chlorine. That means addition of chlorine, removal of hydrogen. It gives rise to chlorobenzene. It gives rise to chlorobenzene. This is an example of haloarenes. This is an example of haloarenes. We observe that halogen is present, that is chlorine, and arene means benzene is present. So the combination of halogens and arenes in a given compound is called the haloarenes. These are produced by which was taken by the starting material is arenes. That means benzene, which is having the general formula, molecular formula C6H6. One of hydrogen is replaced by halogens. Okay, one of hydrogen is replaced by halogen. So we will get the haloarenes. I hope this concept, what does mean by haloalkanes and haloarenes, how they are prepared is clear to you. Now let us try to understand what does present in what explains in NCRT. Okay. Now let us try to understand the first point here. The halogenated compounds persist in the environment due to the resistance to breakdown by solid soil bacteria. Here, these halogenated compounds which persist, the persist which means its living is continue. That means the halogenated compounds living in the environment. Why? Because these are not break down by soil bacteria. So in this way, these halogenated compounds, which was very effective, that means harmful to the environment. Yeah, this statement explains that the halogenated compounds, which are very complicated to the environmental pollution. Okay, I hope this line is clear to you. Now let us try to understand the main concept, what we discussed in the whiteboard that present in the lines. Okay, the replacement of hydrogen atoms in the aliphatic and aromatic hydrocarbon. That means a aliphatic, which means a straight chain. Aromatic means a ring. Aromatic means a ring. So the best example for ring is benzene. The best example for ring is benzene. Hydrocarbons by halogen atoms results in the formation of alkyl halide that will be called as haloalkanes and aryl halides that will be called as haloarenes respectively. So what we discussed in the whiteboard, these are present in the line form. So we previously observed that the hydrogen, okay, now let us try to understand one more time. Here the hydrogen is replaced by this halogen atom to you will get the haloalkanes and in benzene one hydrogen is replaced by chlorine and we will get the haloarenes or benzene aromatic arenes. Okay, I hope up to this is clear to you. Now let us try to understand its hybridization. Haloalkanes contain halogen atoms attached to sp3 hybridized carbon atom of alkyl group, whereas haloarenes contain halogen atom attached to sp2 hybridized carbon atom of an aryl group. So here these two lines indicates the attachment of halogen with the carbon hybridization. Okay. Okay, now let us try to understand in detailed manner. Okay, in the second line we observed that the halogen attached carbons hybridization. Okay, halogens attached carbons hybridization. Here we observe that all our single bonds are present. So single bonds are present. So we conclude that hybridization is sp3. In single bonds, we observe that hybridization is sp3. So the halogen attached carbons hybridization is sp3 in haloalkanes. Now let us try to understand hybridization of carbon in haloarene. So we observe that this carbon is attached with a double bond. We know that the carbon with the double bond undergoes the sp2 hybridization. Which hybridization? sp2 hybridization. Okay, now let us try to understand this. Thus, this halogen attached carbon undergoes the sp2 hybridization in case of haloarenes, but in case of haloalkanes, this halogen attached carbon hybridization is sp3. You have to remember this point. Okay. Many halogen containing organic compounds occur in nature and some are clinically useful. So we observed that these halogen containing compounds which are present in nature, which was useful in clinically purposes, okay, for medicinal purpose. These classes of compounds find wide applications in industry as well as in day-to-day life. By observing these classes of compounds, which was studied in the after the classification of these halogens, which was used in applications in industry as well as in our daily life. They are used as a solvents for relatively non-polar compounds and as a starting material for synthesis of wide range of organic compounds. Here we observed that these are the halogenated compounds CCl3 and CCl4. Here we observe that these are the non-polar ones. These are the non-polar ones. We know the one sentence that likes dissolves in likes. Okay. Here these are the non-polars. So when another nonpolar is present, so these nonpolars are dissolved in another nonpolars. So that's why these halogenated compounds, haloalkanes and haloarenes are used as an solvents. Okay. And the next one is these are used as a starting materials for the synthesis of wide range of organic compounds. Okay. Now let us take an example to explain this concept. To explain this concept for example, in the previous, we discussed that this is the haloalkane. This is the haloalkane. When this haloalkane is reacted with OH minus, this attacks from the back side and Cl is removed as Cl minus. We know that Cl is a good living group. Cl is a good living group. So the product is CH3 bond OH. That means from haloalkanes to alcohols. Haloalkanes to alcohols. By using of these haloalkanes, we can easily prepare the alcohols. In this way, in organic compounds, these haloalkanes and haloarenes are used. Okay, now let us try to understand the next concept. Chlorine containing antibiotic, that means a chloramphenicol produced by microorganisms, is very effective for the treatment of typhoid fever. That means the chloramphenicol, which contains the antibiotic nature of chlorine, which is used to treatment for the typhoid fever. Now let us try to understand the structure of chloramphenicol. So with respect to exam point of view, there is no need to remember this chloramphenicol structure. Here is the chloramphenicol structure. The structure is, here is the structure of chloramphenicol. Here there is no need to remember this structure. Uh, Okay, you have to understand the structure. Here, chlorines, which type of chlorines are present? You may expect question from this. If the examination is tough, they ask the question that which type of chlorine is present in chloramphenicol. Here we observe that one hydrogen is present. So simply we tell that secondary alkyl is present. Secondary chloride is present. Okay, secondary alkyl chloride is present. We observed that how can you differentiate primary, secondary, and tertiary? If the chlorine attached carbon containing two hydrogens, the chlorine attached carbon containing two hydrogens, so this is considered as primary. If the chlorine attached carbon containing only one hydrogen, so it is considered as a secondary. If the chlorine attached carbon is containing does not containing any hydrogens, so this is considered as tertiary amines. So in this way you can classify as primary, secondary, and tertiary amines. Okay, so in chloramphenicol, secondary chloride is secondary alkyl chloride is present. I hope this concept is clear to you. Next one. Okay, this chloramphenicol, this is the structure of chloramphenicol, which is used for the treatment of typhoid fever. Okay, the chloramphenicol. Here we observe that matching type of questions will ask in the examination. What is the use of chloramphenicol? And the next one is our body produces iodine containing hormone thyroxine, the deficiency of which causes the disease called the goiter. I hope this already in biology. Okay, this is the general awareness question. The deficiency of thyroxine leads to the disease of goiter. Synthetic halogen compounds, that means chloroquine is used for the treatment of malaria. What is the what is the treatment? What is the which compound? Which halogen compound? They ask in exam like that. Which halogen compounds are used for the treatment of malaria? So chloroquine is used as the treatment for malaria. Now let us see the structure of chloroquine. These structures for information purpose only. There is no need to remember these structures. Okay, the chloroquine, which is used for the treatment of malaria, which is treatment for the which is treatment for malaria. Okay, now let us try to understand this structure. There is no need to, I am requesting you that there is no need to remember these structures. I draw only for informational purpose. N bond hydrogen, CH3, CH3 bond CH3. So here is the Cl. So here observe that aryl chloride is present in chloroquine. Chloride. Aryl chloride is present in chloroquine. The chloroquine which is used to treatment for malaria. Okay. The next concept. Halothene is used as an anesthetic during the surgery. Okay. We know that halothane is used for anesthetic during the surgery. It gives an it gives an for the anesthetic which is given to the patient before the surgery, okay, without any pain. Second, fully fluorinated. Now let us see the structure of halothane also. Here the structure of halothane is, here you have to keep in mind that these structures which are only for informational purpose, not to remember these structures, okay. C bond fluorine, bond fluorine, bond fluorine, bond C, bond Cl, bond hydrogen, bond Br. This is the structure of halothane. Certain fully fluorinated compounds are being used as a potential blood substance in the surgery. Here we observe that fully fluorinated compounds are used for the blood substance in the surgery. Okay, I hope the introduction of haloalkanes and haloarenes, each and every line is clear to you. The conclusion, now let us try to understand what does you learn in the introduction is that the important points are chloramphenicol. The chloramphenicol, which is used for the treatment of typhoid fever, which is used for the typhoid fever. The alkane present is a secondary alkyl group. And next one is chloroquine. The next one is chloroquine, which is used for the malaria. And here aryl chloride is present. Here aryl chloride is present. And next one is halothane. Halothane, which is used for anesthetic drug, which is used as an anesthetic in surgery. Okay. And last one is fluorinated, fully fluorinated compounds. What is the use of fully fluorinated compounds? These are used as a blood substituents. These are used as a potential blood substituents. Here the chloramphenicol, which is used to treatment for typhoid fever, and the chlorine present is a secondary alcohol. The chloroquine, which is used to treat malaria, and the chloride present in aryl form. The halothane, which is used for anesthetic, which gives the before the surgery, and fully fluorinated compounds, which is used as a blood substituents. I hope the introduction video of the introduction video of haloalkanes and haloarenes is clear to you. I hope each and every point covered in this video. And in the next video, in this unit, we will go to discuss about the important methods of preparation, physical and chemical properties, and uses of halogen compounds. In the next video, we are going to discuss about the classification of haloalkanes and haloarenes. Up to this video, the introduction of haloalkanes and haloarenes is clear to you. If you have any doubt in this introduction, please WhatsApp to me. I will answer, and if you are free, and then call to me. There is no problem. Feel free to contact us, and please share with your friends and family members. And please do subscribe for more videos and updates. This is the live videos. We are conducting live videos daily at 9 p.m. Same time, daily at the 9 p.m. we started the live of English classes. If you are comfortable in Telugu, the Telugu playlist is also present in Growth Online Tuitions, and please share with your friends and family members. I hope this series is which is it gives an boost to your preparation who are preparing or for Neet and Iit Jee, and please do subscribe for more videos.